Here is a slightly involved concept. Although straightforward to explain what the question is, you will take some time to even understand what is this question all about. The question goes like this. Given a function f, how do you show that it is 1, 1? It sounds like, why are we even asking this question? You just look at the pictorial representation of a function. You see that, as I have told you, function is all about someone shooting from the domain onto something in the codomain. You ensure that no two elements of the domain goes to the same element in the codomain. If this happens, we are done. We can call the function to be 1, 1. But then when the function is an infinite function, by that I mean it has a domain with infinitely many values. You cannot pictorially try to see are there two elements going to the same element, right? It is practically impossible to check this for infinitely many elements. So there is a proof technique that you can use. What is that? Let me explain that using a very simple, straightforward example. Consider a function f from positive integers to positive integers defined by f of alpha is equal to 7 alpha. Alpha x, you can use anything. Okay. So basically 1 goes to 7, 2 goes to 14 and so on. Is this a 1, 1 function? Yeah, you can dismiss this in saying, hey, yes, it's a 1, 1 function. It's very obvious. No two elements can go to the same element. But how do you prove it? Let me prove it very, very patiently. Observe, although in this example you feel there is no need to prove, but I'm teaching you how to prove that a function is 1, 1. Okay? When will a function not be 1, 1? When two elements, they go to the same element. Let's assume such a thing is happening here. What do I mean by that? There is a alpha and there is a beta such that f of alpha is going to that element where f of beta is also going. Okay? And they are not the same. Or rather, I'm sorry, they are the same. F of alpha is going to an element, f of beta is another element, and these two things are the same. That is when we have a problem with this function being a 1, 1 function. It will not be a 1, 1 function. So let me assume such a thing is happening. F of alpha is being equal to f of beta. And these two elements, alpha and beta, are different elements in the domain, of course. Now, f of alpha is 7 alpha and f of beta is 7 beta. You know, 7 times a number is equal to 7 times another number means that alpha should be equal to beta. Why? You can cancel off 7 here. Correct? Alpha will be equal to beta. Now, that contradicts the very assumption that alpha was different from beta. In plain English, you know what I just did? I showed that in case alpha and beta goes to a same element according to the function, then alpha and beta will become the same, which means you cannot see a structure like this. You cannot have a alpha and beta different things going to the same element when you say the function is 1, 1. Given that here the function f of alpha is 7 alpha is a 1, 1 function, it doesn't let you have a structure like this. So whenever such a structure is not there, you say the function is 1, 1. And this is a proof strategy. By this I mean, whenever you are given a function f from a domain x to codomain y, and if you are asked to show that f is 1, 1, you should simply say, assume f of alpha is equal to f of beta, and then show that alpha gets forced to become beta, which in itself is a proof that f is 1, 1. We'll see a couple of examples where the function f is non-trivial, that it's 1, 1. It's not very obvious that it's 1, 1, but we'll show using this proof technique that it is indeed 1, 1.